Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea.
Ladies and gentlemen, a blessed day to everyone. This is my 8th lecture in our subject, IT 122, Human-Computer Interaction 2. In my previous lecture, you learned data analysis, such as quantitative analysis and qualitative analysis, interpretation of data using statistical analysis, and presentation of data using charts such as bar chart, pie chart, and scatter chart. Today we proceed on Chapter 5 entitled Design, Prototyping, and Construction. Design activities begin once some requirements have been established. The design emerges iteratively through repeated design, evaluation, redesign cycles involving users. Broadly speaking, there are two types of design: conceptual and concrete. The former is concerned with developing a conceptual model that captures what the product will do and how it will behave, while the latter is concerned with details of the design, such as menu structures, haptic feedback, physical widgets, and graphics, to name but a few. A design cycles become shorter, the distinction between these two becomes blurred, but they are worth distinguishing because each emphasizes a different set of design concerns. For users to evaluate the design of an interactive product effectively, designers must prototype their ideas. In the early stages of development, these prototypes may be made of paper and cardboard, or ready-made components pulled together to allow evaluation. While as design progresses, they become more polished, compact, and robust so that they resemble the final product. Broadly speaking, the design process may start from two distinct situations: when starting from scratch or when modifying an existing product. Much of design comes from the latter, and it is tempting to think that additional features can be added or existing ones tweaked without extensive investigation, prototyping, or evaluation. Although prototyping and evaluation activities can be reduced if changes are not significant, they are still valuable and should not be skipped. Prototyping. It is often said that users cannot tell you what they want, but when they see something and get to use it, they soon know what they do not want. Having established some requirements, the next step is to try out design ideas through prototyping and evaluation cycles. A prototype is one manifestation of a design that allows stakeholders to interact with it and to explore its suitability. It is limited in that a prototype will usually emphasize one set of product characteristics and de-emphasize others. When you hear the term prototype, you may imagine a scale model of a building or a bridge, or a piece of software that crashes every few minutes. A prototype can also be a paper-based outline of a display, a collection of wires and ready-made components, an electronic picture, a video simulation, a complex piece of software and hardware, or a three-dimensional mock-up of a workstation, to name but a few. In fact, a prototype can be anything from a paper-based storyboard through to a complex piece of software, and from a cardboard mock-up to a molded or pressed piece of metal. For example, when the idea for the Palm Pilot was being developed, Jeff Hawkins, founder of the company, carved a piece of wood about the size and shape of the device he had imagined. He used to carry this piece of wood around with him and pretend to enter information into it just to see what it would be like to own such a device. This is an example of very simple, some might even say bizarre prototype, but it is served its purpose of simulating scenarios of use. Advances in 3D printer technologies, coupled with reducing prices, have increased their use in design. It is now possible to take a 3D model from a software package and print a prototype. Even soft toys and chocolate may be printed in this way. These are examples of prototypes or models made from a 3D printer device. Like for example, this 3D printed output that has gears and rods that model a particular piece of component. Another is this 3D printed looking car that as if it is real. This is another example of a prototype which was modeled first using a 3D modeling software such as Blender, SolidWorks, 3D AutoCAD, to name but a few. The 3D artist models the teddy bear using wireframes with color textures and then later printed using a 3D printer device. And it will take hours or even days to finish printing the teddy bear as a 3D model because the 3D printer device is very slow to print a 3D object. Why prototype? Prototypes are useful when discussing or evaluating ideas with stakeholders or customers. They are a communication device among team members and an effective way for designers to explore design ideas. The activity of building prototypes encourages reflection in design, as described by Sion, and it is recognized by designers from many disciplines as an important aspect of design. Prototypes answer questions and support designers in choosing between alternatives. Hence, they serve a variety of purposes. For example, to test out the technical feasibility of an idea, to clarify some vague requirements, to do some user testing and evaluation, or to check that a certain design direction is compatible with the rest of product development. The purpose of your prototype will influence the kind of prototype you build. For example, if you want to clarify how users might perform a set of tasks and whether your proposed design would support them, in this, you might produce a paper-based mock-up, prototype, or model. The figure on the right shows a paper-based prototype of a handheld device to help an autistic child communicate. This prototype shows the intended functions and buttons, their positioning and labeling, and the overall shape of the device. But none of the buttons actually work. This kind of prototype is sufficient to investigate scenarios of use and to decide, for example, whether the button images and labels are appropriate and the functions sufficient, but not to test whether the speech is loud enough or responds fast enough. Low fidelity prototype. A low fidelity prototype does not look very much like the final product and it does not provide the same functionality. For example, it may use very different materials such as paper and cardboard rather than electronic screens and metal. It may perform only a limited set of functions, or it may only represent the functions and not perform any of them. The lump of wood used to prototype the Palm Pilot described previously is a low fidelity prototype. Low fidelity prototypes are useful because they tend to be simple, cheap, and quick to produce. This also means that they are simple, cheap, and quick to modify, so they support the exploration of alternative designs and ideas. This is particularly important in early stages of development during conceptual design, for example, because prototypes that are used for exploring ideas should be flexible and encourage exploration and modification. Low fidelity prototypes are not meant to be kept and integrated into the final product. They are for exploration only. Storyboarding. Storyboarding is one example of low fidelity prototyping that is often used in conjunction with scenarios. A storyboard consists of a series of sketches showing how a user might progress through a task using the product under development. It can be a series of screen sketches or a series of scenes showing how a user can perform a task using an interactive device. When used in conjunction with a scenario, the storyboard provides more detail and offers stakeholders a chance to role-play with a prototype, interacting with it by stepping through the scenario. The example storyboard shown in figure below depicts a father fetching his daughter to come home. The drawings or sketches are simple, and labels or dialogues or scripts make the storyboard easy to convey a message, a story, or a scenario. Another example of storyboard depicting how to fill a car with a gas. In drawing or sketching a storyboard, you do not need to become a great artist like Picasso, Vincent van Gogh, to name but a few, to make the storyboard a work of art. You can draw stick figures of humans as simple like that, but you must place some labels so that the reader can guess the story, scenario, or the message. Sketching. Low fidelity prototyping often relies on hand-drawn sketches, and many people find it difficult to engage in this activity because they are inhibited about the quality of their drawing. But as Greenberg put it, sketching is not about drawing, rather it is about design. You can get over any inhibition by devising your own symbols and icons and practicing them, referred to by Greenberg as sketching vocabulary. They do not have to be anything more than simple boxes, stick figures, and stars. Elements you might require in a storyboard sketch, for example, include digital devices, people, emotions, tables, books, etc., and actions such as give, find, transfer, and write. If you are sketching an interface design, then you might need to draw various icons, dialog boxes, and so on. Some simple examples are shown below. The next activity requires other sketching symbols, but they can still be drawn quite simply. I posted your 8th assignment in our Google Classroom. Please answer and accomplish it.
That ends our topic for today. I hope you have learned in my class. Thank you for watching. Carry on until tomorrow. God bless us.